Here we have a SAT math question. There is an xy plane given over here. In the xy plane above, the graphs of y equals x square negative 4x positive 5 and y equals x positive 1 intersect at points B and C. What is the area of quadrilateral ABCD? So in the xy plane over here, we have to find the area of this quadrilateral ABCD. Okay, to get the area of this quadrilateral, what I'm going to do is I'm going to split up the quadrilateral into two parts. One is the right triangle over here. Okay, let me assume the point over here is E. So, and we have a right triangle BCE and we have a rectangle ABED. So, I just split up the given quadrilateral into two parts. One is right triangle and the other one is rectangle. So, to get the area of this quadrilateral ABCD, what I need to do is I have to find the area of this right triangle and I have to find the area of this rectangle. Then I add them to get the area of the quadrilateral ABCD. Okay, so to get the right triangle BCE over here, I need the base, the length of the base and length of the height. So that I can use the formula to find area of a triangle, that is base times height divided by 2. And also to get the area of the rectangle ABED, I need the length of the rectangle and the width of the rectangle. So I can use the formula to find area of rectangle, that is length times width, to get the area of this rectangle. So to get the base and height of the right triangle and the length and width of the rectangle, I need the point of intersection of the quadratic equation, quadratic function y equals to x square negative 4x positive 5, the parabola, and the linear equation, that is the line y equals to x positive 1. Okay, so to find the point of intersection of the parabola and line, what I need to do is I have to solve the given system of equations. Okay, so for that, what I'm going to do is I'm going to take the equation of the line, which is y equals to x positive 1. Okay, to solve the given system, I'm just going to use the stuff which is equivalent to y in the first equation. In the first equation, in the equation of parabola, so x square negative 4x positive 5, this is a stuff equivalent to y. So I'm going to plug in this stuff for y into the linear equation over here. Let me do it. So because I am solving the given system of equations, so we get x square negative 4x positive y equals to x positive 1. I just mixed the two equations to solve the given system to find the point of intersection of the parabola and line. Okay, now let's solve. This is a quadratic equation. Okay, to solve a quadratic equation, we have to get the quadratic equation standard form, that is ax square positive bx positive c equals to 0. That is, to get the quadratic equation standard form means we must have everything on the left side and 0 on the right side. Okay, so to make the right side 0, I have to get rid of this x and positive 1. So I subtract x from both sides and also I subtract 1 from both sides. So when I do so, this positive x, negative x will cancel, positive and negative 1 will cancel out. I'm getting x square. And when I combine negative 4x and negative x, I'm getting negative 5x. When I combine positive 5 and negative 1, I'm getting positive 4 equals to 0. I think this quadratic equation can be solved by factoring. So to solve a quadratic equation by factoring, we have to multiply the constant term by the coefficient of x square over here. So here there's no number in front of x square. We have to assume the coefficient of x square is 1. So when I multiply this 1 and the constant of positive 4, I am getting positive 4. 1 times positive 4 is positive 4. Now I have to get two factors for this positive 4, so that the product of the two factors over here must be equal to positive 4. When I add them, it must be equal to the coefficient of x, that is negative 5. I think negative 4 and negative 1 will work. Okay, so to get the two values for x in this quadratic equation, I just have to change the signs of these two factors. When I change this negative sign, it will become positive 4. When I change the negative sign in the second factor, it will become positive 1. So now I got the two values of x, 4, 1. So definitely we'll be having two values of x because the parabola and line intersect in 2 points. Okay, to find the corresponding y coordinate, we need to plug in x equals to 4 and x equals to 1, either into the equation of the parabola or the equation of the line. So better we can plug in x equals to 4 and 1 into the equation of the line y equals to x plus 1. It will be easier for us to do calculation of y. So let's plug in x equals to 4 into the equation of line, that is y equals to 4 positive 1. I'm getting 5. So the point I'm getting over here is 4 comma 5. Okay, now let me plug in the second value of x, that is x equals to 1 into the equation of line. Then I'm getting y equals to 1 positive 1, which is equal to 2. So the x coordinate over here is 1, the y coordinate I get 2. So the second point is 1 comma 2. I got the 2 points of intersection of the parabola and line. So it has to be 1 comma 2 because so here it has to be, the x value has to be 1 and here x value has to be 4 because we get two values of x, 4 comma 1. Okay, let me finish. And also here the y value has to be 2 and because we got the y value is 2 and here the y value has to be 5 corresponding to C. Okay, now let me mark it. Just a moment. Okay. So now I got the points of intersection 1, 2 is here, and the other point 4, 5 must be here. So these are the 2 points of intersection. Okay, now let's find the height of the triangle and the base of the triangle. So this EC represents height of the triangle. We can get the height of the triangle by finding the distance between the 2 and 5 on y-axis. So that's clearly 3. The distance between 2 and 5 on the y-axis is 3. So the height of the triangle is 3. And to get the base of the triangle, we have to find the distance between A and D. So at A, we have 1 on x-axis. At D, we have 4 on x-axis. So the distance between 1 and 4 is 3. So the base of the triangle is 3. And also, let's find the width of the rectangle. So with the width of the rectangle, this represents the width of the rectangle. Clearly, this distance is 2 units. And also, the length of the rectangle is 3. Okay, now I have the length and width of the rectangle and the base and height of the triangle. Okay, so first what I'm going to do is I'm going to find the area of a triangle. Area of the right triangle. 1 second, let me do it. Area of the right triangle, BCE. So for that, the formula is the base times height divided by 2. So the base of the triangle is 3 units. And the height of the triangle is also the same 3 units. 3 times 3 divided by 2. Which is 9 over 2, which is equal to 4.5 square units. Okay, now let me find the area of the rectangle. Let me do it. So area of the rectangle. Area of the rectangle is equal to length times width. So the length of the rectangle is 3 units and the width of the rectangle is 2 units. So 3 times 2, which is equal to 6 square units. Okay, now I got the area of the triangle, area of the rectangle. So the area of the triangle is 4.5 units and the area of the rectangle is 6 units. Okay, now let's get the area of quadrilateral ABCD. To get the area of the quadrilateral, what I need to do is I have to add the area of the triangle 4.5 and area of the rectangle 6, which is equal to 10.5 square units.